Good morning, everyone. Today is the July 12th, and it's our weekly updates. And a few of us cannot join, I think, because it's the vacation time and it's summer time. So let's start. And our first topic, Daniel, do you want to talk about the dynamic resource reservation? Do you need the permission to share slides?
Yeah, that would be great.
Let me find.
Okay. Still don't have the permission. Anyways, hi all, I'm Daniel. I work for SAP. I've been in this meeting not many times before. And today I wanted to talk about a enhancement proposal that I have talked about already a couple of months ago. And I can only show, there's also some comments on that in the Google Sheet. Let me try to share now. Okay, now it should work. Okay. The last time I talked about it is here. There were also some comments here that I tried to address over the time. Yeah. Anyways, just to recap, because it was a while ago, the main idea behind it is targeting kube and system reserved settings in the kubelet that are currently statically set. And the idea would be, instead of setting these things before calculating the target reservations before the kubelet starts, for instance, like AKS, GKE, or a lot of other players are doing it, it would be nice to be able to do that at runtime, actually. So and why? So this is the motivation behind it. We have seen on our landscapes we're essentially operating a Kubernetes as a service internally at SAP, and so we have a bunch of clusters running, and we have seen that the resource reservations that we are setting, we have a similar heuristic based on max pods and these kind of things, that these reservations that we are setting statically don't really reflect reality. For one, it depends on how many pods you're running, obviously, and also what kind of workload is actually running. And so we have seen, for the same amount of pods deployed, sometimes also max pods, we're typically doing like 200 or 250, so the maximum possible. We are seeing vastly different numbers regards to utilization, and also in regards to how much memory and CPU actually container runtime is using mostly. Also the kubelet, but the kubelet we have seen typically scales with the amount of pods deployed. Or not scales, but the amount of memory it needs and CPU. So in general, sometimes we have too high reservations for clusters with very inactive workload, meaning we are achieving a low utilization that would cost a lot of money. And on the other hand, we have, for very busy clusters, typically the ones that are hosting a lot of control planes of other clusters, we see that we are not reserving enough. And then under some circumstances we have seen some CPU starvation or system level out of memory issues, because the C group limit on kube pods that is set from system kube reserved is too high, actually. And that's why we see these problems. And without restarting the kubelet, we have no time. no option to adjust it, but it's not really a good option to restart the kubelet. So that's would be one of those reasons why it would be nice to adjust that at runtime. Maybe just a second. For instance, if let's see. Okay, now it's just burned. Reload that real quick. I thought it would be nice just to see it real quick what I'm even talking about. Anyways, if this, I'm just port forwarding at the moment. Essentially, I just wanted to show you real quick that we see vastly different numbers. This is just a random cluster here. If you see this here on the right, this column here, we see very different working set sizes, for instance, for system slice, vastly different numbers ranging from 2 to 8 gigs. And that's already when we have 100% requests. And also when we calculate how much memory we should reserve, then it also varies from like here 1 gig to sometimes 7 gig or 6 gigs. So it really it's vastly different, and that's the main motivation. So yeah, what in the past I've also, one of the reasons why that is, for instance, for CPU that I've checked is the container logs to standard out, right, and then go through a pipe, and then the container shim decorates those logs and writes it to the kubelet and varlog pods and so on. So if we have a container that does a lot of logging, that influences the container runtime CPU requirements. That is one of those reasons why that could happen. And for the amount of pods is because the container shim, for instance, is part of the container runtime C group. Anyways, that is the main motivation why that would make sense from our point of view. The long-term goal would be to, for one, of course, prevent issues in our stakeholders clusters, because we don't control these clusters typically maybe like GKE. We don't control clusters from our stakeholders, so we would like to prevent issues in those clusters. And we also don't set their system and kube reserve settings. We just do it with this static formula. But for us, certain stakeholders sometimes rely too much on these safeguards. And they're just, for instance, in one occasion, someone is relying on kubelet eviction, and they basically have a memory leaking container. And if the C group limits are not properly set, no eviction will take place by the system level OM. And that's just one of those instances where we then have to go in there and explain and try to find the right settings for kube and system reserved, and that is causing effort on our side. And the other topic is, of course, utilization. Just to be able to safely increase that would save a lot of money. Yeah. If you have any questions or something like that, please just ask. If I'm not making sense, just tell me. Otherwise, I would go to 2 concrete proposals, and that would also be included in this draft cap. Okay. So the
one question maybe.
Sure.
You were mentioning that you want to increase. Usually, the case is that you want to increase the size of those resources for system reserved and so on. Right? Or
what do you exactly mean by the size of the resources? Maybe I misunderstood.
Like you want to take more cores, more memory, correct? Or
yeah, we want to adjust it based on the actual needs on that node. So if it needs less, we would reserve less. If it needs more, we want to reserve more.
Okay, but if it's fixed, usually for you it's not sufficient, or it was too much?
For the majority of cases, a formula like GKE or Azure over-reserve, and I think that's the main purpose behind these static reservations, to have an over-reservation, but we also see that in certain cases, we do not reserve enough. So we have like, it's never really correct for us. That's the main reason.
What's the overhead? But most probably you will mention it later, but what will be the overhead to determine this automatically or basically in runtime?
Yeah, I've actually built a POC for this, but essentially what I think you need is you need to, for instance, on Linux systems, you would need to check regularly, like in reconciliation fashion, proc mem info, just check how much really memory you have available on a system, plus need to check some C group stats from QPods, for instance, the overall. And for CPU, for instance, measure the real free CPU time. I think CAdvisor already has that.
And how many CPU cycles will you eat with that?
Of course, it depends on the recommenders, if I call the process like that, implementation. So I can't really answer it, but it wasn't much, maybe 20 millicores, 15, not sure, but that's just, yeah, from a POC level.
Mm-hmm.
Yeah, so I think that is then an implementation detail, right? I mean, but of course it matters how to get these metrics and how to then make a decision based on those. Definitely matters. And I think that ties well into those two proposals here. So the first proposal is actually to run some external recommender process, whatever that is. That wouldn't be part of core Kubernetes. And this one calculates however they want to do that. For it could be obviously different for Windows and for Linux, a recommendation. And the kubelet would have a means of telling it what system reserved and kube reserved it should have. So that it wouldn't be only through the config file like here on the left, but you could do that at runtime. One idea would be to expose like a gRPC server that would be similar to, where is it? Here, to the pod resources. I think they do the same thing already, but where you can get some stats over for some pods and containers currently run. Essentially, the kubelet could also create a Unix socket and call it, I don't know, under dynamic resource reservations, and it has an API where you can post and get the current reservations from. So you can have an ability to reconcile it.
A question about how frequent kubelet will report this change the allocation to scheduler on the node resource, because it's going to impact the scheduling decision going forward, right? We have C issues like static pod, the resource consumed by static pods being reflected at the scheduler side, at the node object side with the latency cause scheduling failure. Or kubelet run out of resource for the pod to start on the node. How do we mitigate that with the changing allocatable resource here?
Yeah, I think that's one of the biggest difficulties, and that's also one of the things that should probably be talked about when in this cap, because yes, you're changing. That's essentially like changing the config, right, on the node, making a different Kubernetes system reserve, what today is already possible, but you just do it a lot more often. And so, yeah, it is really, you will have to see what impact it has on the scheduler exactly. Yes.
And I think one thing we'd have to consider is how does it impact the running workloads as well? So if your system is consuming more resources and you decide to allocate it more, does that mean that we have to start evicting the existing pods that are running on the cluster. So I think that would be very important as well.
I actually think that is, I haven't tested this yet, it was on my list, but I think that that's what the kubelet would do. So if for some reason the system reserve, so like your container runtime needs so much more memory, then it could happen that you have more pods, right? Then more reserved on your pods than you actually have allocatable. And yes, so there are certain things we have to take care of, and that obviously would need to be thoroughly tested.
Hello.
I would like.
Go on. Sorry, go on.
I'm just curious. Can we try to solve it with a bit more generic solution, not just for reservation? What I mean by that is what right now our kubelet detects the available node resource once during the startup time and never changes it afterwards. So all kind of problems like the CPU hot plug or offlining or memory hot plug or offlining practically require to restart a kubelet. So instead of just the reservation part, can we probably think about what kubelet available resource discovery will be dynamic? Well, like the whole set of resources.
The Alexander, this is the fundamental problem. Scheduler is not doing the usage or available or while scheduling, right? So the problem it is when we report, when node come back and register and we report back, say here's the available, here it is the machine capacity, here's the available resource. Scheduler just take that one. So it's not really consume of, so they don't expect those change. And also they don't expect there's the usage take into consideration when do the scheduling decision. So that's why we end up have the static report back. Yeah, I totally agree with you. And we could make that more dynamic yeah.
So let me clarify. So the current capacity and allocatable is part of a node status part of a node object. So it's something what is dynamically updated from time to time. So for scheduler, in theory, it should be no big difference, like read it once or read it every time a node is updating the status.
I think the allocatable is the value that is capacity minus reserved. It is not taking into consideration the resources occupied by the pods itself. So that's why scheduler doesn't know the actual utilization of resources, and it has to compute every time it tries to schedule a pod.
Yeah, well, that's fine, Swati. What I'm saying is what, like, instead of just trying to make one parameter, like reserved resources, change it. Like, let's have all the capacities to be dynamically adjustable during the lifetime of a kubelet.
So let's not go to the capacity first, right? So capacity, let's assume, make the problems simple today. Let's just talk about allocatable, which is what Daniel proposed here, dynamic, right? So here's the problem. Because at any given time, and the resource usage, just the simple cases, just only like the system usage, kernel usage, and also those system daemons usage. At a given time, they may be like the one T0, the usage got to peak, and the T1, they dropped, and how we are smooth those kind of things, normalize those things. Right, so that it is need to take consideration. And sometimes those usage go up and down, actually rely on the workload, right? So it's not a workload. Workload also, like, especially for a lot of the burstable, their usage, it is sometimes it's go up and go down. And sometimes when they go up, and we also will trigger off the system thread, certain kernel thread go up and down. So how we are going to smooth those things? That's the more fundamental problem. And so this is why, because in the past, we didn't have that as like average, like normalized data, and we didn't report back to the scheduler. So this is why we take the approach on the node side, make that over reserved, a little bit over reserved, and also like to try to be the more static. That's the fundamental problem. But in the Borg, in the past, we did in the node, we do those normalization. We base on the given time and the moving average and report to scheduler. Scheduler take that into consideration, and so then we can be more dynamic. Unfortunately, we think about that's really overcomplicated when the initial design, especially with the scheduling design. Even today, I think that's still think about it's over complicated. So this is why we never really doing those moving average to report back. So that's why end up on the node side, because we have to protect the node, right? The one things you definitely want to prevent it is out of disk, out of memory, right? Especially out of those things, because you could tear down the entire node, and out of memory even could cause of the disk corruption, right? Data corruption issues, and hold like the node it is go down. So that's kind of things we take the strategy. Of course, even without those average, those things, you still need. The only thing is why we are more conservative today. It is because we don't take into consideration. We could also always at runtime reject it, right? So we don't report. Scheduling oversimplify, but we don't report. But when the scheduling job to here, and we base on the current usage, based on the current allocatable and reject, but that could cause of the cascading problem. You keep just reject and the schedule keep scheduling on the same node. So that's all scheduling try to avoid that kind of thing. Then we'll do another level of the ad hoc fix. So this is why I kind of like at the earlier time, because for the simplified scheduling, and I decided to make this also is oversimplified, but to satisfy customer. So I made that is the flag or config. So based on your working environment, like some customers say, oh, I have the large node, but even at my large node, I only have the one pod. How much management resource you are needed, right? So you could on the node, at the node come up time, and administrator can say, here's this node, and I tag the node, label the node, and then make some changes small, like the reservation much smaller. So that's kind of flexibility back then, the decision I made it. Yeah, so I just want to explain some background and the context why this is complicated. But at that time, we open to, if scheduler open to take some consideration, to take some usage a while scheduling change, we are totally open to calculate, give more smooth data, like the normalized data, and back to the scheduling, and we can do more advanced enhancement here.
Yeah, thanks for the background. I think that my question would be, currently we already allow changing the allocatable, right? Like someone else already said before, sorry, I missed the name. So it actually would just update the allocatable like today, right? And sure, maybe if I understood it correctly, you were saying that if that would happen while the scheduling decision happens, then that could lead to problems during the scheduling process, if I understood that correctly. The thing is this, how often that happens, right? How often you update the allocatable it would be similar to how often do you restart currently the kubelet process, and how often do you change the configuration in the kubelet. So
well, allocatable, for example, can be changed if device plugins goes up and down. That leads to update with a node resource status.
Okay, yeah, I was talking about memory and CPU in this sense, but yes, you're right, sure.
So there is one more angle to it, right? Like if you think about the overhead at stable state, it's mainly about like running probes. Like kubelet is gonna scale linearly mainly with number of pods, and the runtime's usage is gonna depend on the number of probes you're running. So another way to tackle this is to adjust the pod overhead dynamically on the basis of number of probes you have and how frequently they run. So we have a fixed pod overhead right now, right? And that would also require running your monitoring process inside the pod C group. So in Cryo, we have an option where you can either run your shim either in the system slice or you can run it within the pod slice. So that way, like the pod is charged the cost of running the probes. And if we know how many probes the pod has, then we can dynamically adjust the overhead for that pod. Just another way, I think, to approach this problem.
Interesting. Yeah. So basically, you're charging it on the pod just to adjust the pod overhead.
Look, the pod overhead is not adjustable right now, but that's one way it can be tackled, right? Right now it's fixed, but we do provide an option to charge it to the pod slice. And if we make the pod overhead dynamic, then you don't have to change the other things, right?
Yeah, if you can, I'm just thinking, if you can make sure that that's the only thing that increases kubelet and container runtime usage, right?
Yeah, mainly it's that based on our observations, like at stable state, when all your pods are running, like exec probes is the biggest offender, and then and how often you run them. The rest of it is mostly linear.
But Manu, how he do that? Because based on his problem, the cluster is not under his control. So how can you just think about the
Yeah, the kubelet itself is like dynamically calculating the pod overhead on the basis of number of probes and how frequently they are run. I mean, it won't solve this entirely, but it will make it more. I mean, it will solve part of it, right? I mean, you still need to worry about pods and containers that are using that have a memory leak and stuff.
Yeah.
Ronald,
I think so go ahead, sorry.
Ronald, does that take into account like if the system has say 16 gig of memory and you have a system reserved of 4 gig and that's too much, does pod overhead help utilize that, the 4 gig capacity which is not being used?
No, so I mean, this assumes that you're charging your shim processes to the pod slice, right? So your system reserved, like your system reserved can be more accurate. It's not going to change much because the overhead is charged to the pod itself. But right now that pod overhead is a constant. What I'm saying is we can look into making that more dynamic.
That should be easy.
Yeah, and kubelet can calculate, right?
Yeah.
How many probes you have, how often they are running, so how much overhead to add to the pod.
Okay, I was wondering where if the pod overhead is taking, like you're charging some to the pod overhead, does that come from the system reserved side of things, or is it part of the kubelet's overall? Okay, this is your playground. This is what you can do.
No, it comes under the cube pods, right? Because it goes under it's added to the pod slice.
Okay, then does it really solve this like over configuration of the system reserved?
No, it doesn't change, but at least your system reserved is not going to vary as much, right? When you start charging it to the pod.
Okay.
Right now it's variable because the shim is running in the system reserved in this example, and it can vary dynamic. It varies a lot because of the probes and things that aren't in your control.
Yeah. So basically, the overhead we introduce it is want to more accurate to charge those usage, right? Probe the usage, all those kind of things. So what the menu suggests is just make that it is charged to the right owner, right users here. So then in that case, it's the kubelet system, and all it could be pre-reserved, much smaller,
right?
More accurate here.
Okay.
Yeah.
And more static, right?
Right.
Yeah, even more static. Yes, exactly.
I think it could at least. Go ahead, sorry.
Yeah, Manu, I have a question. Does the CPU limit and the memory limit and other resource limit apply to that pod overhead resource?
Right now it's memory and shares, if I remember correctly. I know it's definitely memory. I'll have to take a look and see if,
Yeah.
if it shares as well. Yeah.
Thanks.
Yeah, I think it would at least get rid of this, the most common problem, right, with how many
Yeah.
pods you deploy. So have
Right.
that more static. Okay, yeah. Then the other thing would be then the amount of work, the kind of workload, right? That would be out of scope of that, but it would definitely help.
Yeah, right. And that'll definitely help. Of course, and there'll be some workloads that won't fit under that.
Yeah, and
No, that's the one things we didn't address. I know what you propose actually is charge to the pod slash. So that's, but when we first want to do the pod overhead, we do think about move those kind of the thread into the per pod SIG group. So like the charge is really the owner.
Yeah. Right.
So we
Yeah.
have to finish that. Yeah.
Yeah, that's what we are doing, Don. Like in Cryo, we are charging it to the actual pod, not the top level cube pod slice. It goes to the pod. And if we can make this more dynamic, then I think it will solve more problems.
Yeah.
And actually, for VM-based runtimes, it's also should be properly charged inside VM, not outside.
Right. Yeah.
I took a quick look at the KEP, and I think I am supportive of the external monitor idea. If there various innovations can happen, eBPF is probably a good way to do it. One thing is definitely would want to run this by the SIG scheduling folks to see what they feel about modifying the node allocatable, because it's definitely going to affect scheduling decisions. I've had to explain things to them just for the pod resize part of it. This is, approaching another introducing another variable for them. And then we want to see if Don's thoughts about usage as well, if something that can be used to make this better.
Yeah, my understanding is the scheduler is really optimized based on assumption, those stableness. So
Yeah.
The pod vertical scheduling, those kind of things actually at least only affect of the single pod, but not against the entire of the
Exactly.
the all pods in the node. So they are really keen about that. Yeah. So.
Yeah, this would introduce a race. The resizing a single pod has a race condition possibility, and we use the max to mitigate, to kind of prioritize existing pod resizing. Now, this is like resizing a node as far as the scheduler is concerned, and that would affect all pods that are being, being evaluated for a particular node fit. And definitely would run this by the SIG scheduling folks and see what they feel.
Yeah, good tip. I'll definitely do that. That makes a lot of sense. Actually, that was also one of that's one of the major unknowns for me. It's also hard to test, but yeah, makes a lot of sense. Yeah, you have looked at the draft PR, right? The draft cap that I posted.
Yeah, I cursorily looked at it. I'm sorry, I didn't go through it in detail.
So I think that's where I included this picture. This one is an alternative one that is more similar to the VPA, how that one works. So that would be an alternative, essentially, that I just wanted to quickly show you. So instead of the kubelet having a gRPC server, we could also just say, okay, we don't have any of that. The kubelet just still only watches node resources, doesn't have a gRPC server, and we would introduce, like in the specifications, a queue preserved and system reserved that field. And if later you want to have also eviction hard or something like this, these kind of settings, you could also introduce that in the spec and say, okay, instead of running through the kubelet configuration, you just can specify these settings on the node itself. And then you would have metrics that can be used by an external control plane that does it for all nodes, right? Similar to the VPA that gets it through the core metrics pipeline, and then can update according to some algorithm or specification. And that would be an alternative.
I'm glad you looked at the VPA side of things. That was something I was going to suggest. Okay.
Yeah. So that I would say maybe if I open that draft or go through also to SIG scheduling, that I would also then show different proposals, maybe these two. I'm currently kind of preferring this alternative implementation, just because it probably wouldn't even require running like a daemon set or something like this, because typically people have already node exporter deployed that already gets like metrics from proc mem info. And then maybe through C advisor, you could also get some other metrics from the C groups that would be required to calculate the reserved resources. And then it would be not very intrusive. So
so you're watching what the recommended, there is a default, and then you're going to watch for what the recommendation for system reserved is. I like this better too.
Yeah, currently the kubelet, correct me if I'm wrong, also watches nodes, right? And just if somebody just nothing would change essentially, just still watches the node resource. And as soon as someone like our reserved resource recommender control plane, if it's deployed, changes something, then the kubelet would adjust the C group limits on kubepods based on that. So the main difference here is just it doesn't have a gRPC server. It goes through the Kubernetes API. It's a little bit more Kubernetes native. Yeah, but then you have a little bit, then you need to go through Prometheus and these kind of things like VPA does it. No, okay, that was wrong. Doesn't go through Prometheus VPA, but yeah, it's just a little bit of a different approach. And I think the details can be discussed also when I open the draft cap, if you like, if it goes too far now. There are also other topics. And I wrote down some dependencies. For instance, everywhere we should add there, of course, the scheduling dependencies, right? What happens then? What happens for eviction if you change that a lot? And also in the kubelet code itself, what happens? Basically, I need to check wherever we assume static resource reservations that needs to be looked at. For instance, as far as I remember, in the CPU manager in some places, that's the case. And also with this memory quality of service feature flag that's currently in alpha. And
the memory manager as well.
Yes.
Okay. Yeah, makes a lot of sense. Yeah, exactly. So there are certain dependencies that would need to be looked at.
Do you plan to benchmark that before and after to see if there's value?
I think that would make sense when implementing that, to make sure that there's nothing going wrong or unexpected.
Not only in terms of correctness, but in terms of performance.
Sure, I think that makes sense. I don't have a lot of experience how to do that, so I would have to reach out to some of you. But I'm certainly that would make sense, I think. Yeah, so these are all good points. Sure, makes sense. I'm coming to the end here. I don't want to take too much of your time. So I think the main questions for me would be, is that something that you guys think is valuable, and if so, how would be the process going ahead with this? Would I open a draft cap and then more discussion takes place there? Or how would that go? So I'm just not quite sure about the process itself. It seems to, well, from what I read is you need to have some traction, right? That's what I read from the documentation. So I'm not quite sure how to quantify that. I mean, the issue is open since a while. On our side, we still think it makes sense to implement such thing.
Daniel, to solve your
and that's why I'm basically here to talk about the session. Sorry, go ahead.
I just want to know that, can you hear me now?
Yeah, sorry.
So I'm wondering, after the menu suggests, based on your particular problem, right? So your customer, your problem, do you think about the menu's proposal can solve your problem?
The biggest thing for us is actually is not so much the amount of pods deployed, because we typically have the max amount of pods deployed. So for us, it's pretty deterministic, this part at least. But what is not really deterministic for us is the amount of workload and the kind of workload running. So that's the bigger issue from our side. So that's why it would be good to have that pod overhead if you're talking about this.
Yes.
To have that, if that.
Yeah. Actually, what menu suggests is not really only number of the pod run, number of the content. Also, it is workload specific, because a certain pod request of the probe and request some logging and other things that also consume of the resources. If we don't properly charge those to the pod and overhead, and then you will charge to the Kubernetes system. So that's kind of like the make that it is unstable and not static, not accurate. So if you could to try what he suggested here, and then we actually, you could, because one of the another set of problem, you say that you don't want like the GKE overcharge, right? So the over reserved based on the machine size and the production, because you are not control about the cluster as GKE. So you want to give the more flexibility. So you want to reserve even more smaller. So after that, the overcharge to the pod slice, the cube pods. So then even like the particular pod, you could estimate down about your cube system reserve here. That's, I think, can solve your original goal there. So there's another problem. Alexandra earlier mentioned that make this the whole things more dynamic. And that's the even more complicated problem. This is why I mentioned that scheduling a while, that's the more generic solution. But at this moment, based on your problem, your production, I do think about what Manu suggests might be the solution, solve your problem. So maybe we could start from there and say, do we need to do this implementation, do this change? We could come back this one, make that even more generic. But I do think about to solve your production issue, Manu have the really great suggestion there. That's how initially we started the pod overhead.
Just one comment on that. Once you end up doing that, you probably have better node stability in that these overheads will be constrained, because they're not really constrained today when they can kind of fight. So if there is kind of a noisy issue, it's constrained just to the pod and not to the other workloads running. So this is positive. The negative side is that now you are going to expose this overhead most likely to the end user, that they will be consumed for this. So in my experience, this is the drawback challenge of pod overhead that will have to be understood, where someone says, I started a 50 millicpu pod with 1 meg of memory, and you have this overhead in place, even if it is dynamic. How they view their resource quota, depending how sensitive they are in their namespace, this is something to be understood.
I'm currently wondering, could I centrally enforce this and calculate these pod overheads? Because I don't have, I assume that's possible, right? To do that. Currently you cannot, the pod overheads are statically defined as far as I understand it. And if there would be a way to calculate those overheads dynamically, then that could solve the issue, right? That would be then good. So
yeah,
I'm not quite sure how, I mean, you said, yeah, go ahead.
Yeah, I think that's where we can start, right? Like one way is looking at the exec probe frequency. I think if we have a way to add an overhead for that accurately, then that will solve most of it. So that's where I think we can start experimenting in this area. Like how can Kubelet look at the pod spec and adjust the pod overhead?
Or use eBPF to get signals.
We could. Yeah, exactly. That's exactly. There's the two things I want to comment. One, it is we are using that to estimate and the feedback loop, and then guide the customer, right? To how you. Another thing, it is the customer, because that's the overhead the user should pay. So customer didn't estimate that correctly initially. We get that's a static one. So if the customer want using more, even they are guaranteed today, so they may be killed, and that damage constrained by that pod level, right? Pod C group either be wound killed or whatever, slow down. So then they could make that burstable, right? First make that burstable, and did the measurement again, even without the vertical auto scaling, and they still could make that burstable and then measure themselves, and the next time to make that is at the pod level to share. So they still have the way to do these things to move forward. But I don't think about that. I do think about that blind charge to the system. That's the wrong. We did that initially because that time is too early. I said we did that initially, but the reason we introduced the pod overhead, it is try to solve this problem, especially after we have like the VM workload to support, right? So like the Kata container, the overhead, it is much bigger than the POS container. And so that's why we want to introduce this configurable at the first place.
Just on top of my head, trying to understand, essentially then the kubelet would need to somehow determine how much CPU and memory, if we just talk about this, overhead it causes for system slice processes, right? So I'm trying to understand how it can do that without monitoring, for instance, the standard out, how much a pod is actually writing at what frequency to standard out. How would it be able to practically do that? That's what I'm trying to understand. Because you would need to have some, I don't know how yeah, just it seems to be you need to find every single or a lot of the single reasons how a container process can influence the memory and CPU usage. So you're going the other way around. And to me, just on top of my head, that sounds difficult, but I'm sure you have a lot more experience doing that. It seems to me more the other way around, just looking at the whole system itself seems to be a little simpler.
If everything is in the appropriate pod C group, like if the way Cryo sets up, you can easily always know what the overhead is, in that it's the sum of container, the workload has their own unique C group as a child in there. If you subtract that from the pod C group, you'll know exactly what the overhead is. The problem is, what do you do with this information? Your pod's already running. Vinay's been doing vertical pod auto scaling for at least a couple of weeks, and it's challenging to manage that on how to adjust then. And then better would be able to look at it and say, heuristically, I'm familiar with this workload. I know what the runtime characteristics are, but I think that that's a whole different challenging problem. And should that be done at the node or the scheduler? You know, today with it being static, the scheduler knows, so it can pick a node appropriately, knowing that the sum of container requests and the overhead is what it needs to take into account. If we don't know that, what the overhead is, then anyway, if it could be dynamic, it'd be pretty interesting and nice. It's just complicated.
Sorry to interrupt it. I really need a time checking here. We only have the 5 minutes left, but we have still two items. But the two items I know it's just the call out attention, so that's why. And so maybe Vinay, you can quickly update and then what you lead, and then we move forward. And also,
yeah, I was on vacation last week, so nothing much to say about it. But the only thing I had to do was rebase it and get to the latest code. Outstanding issues that are they're tracked in my wiki, and I got, before I went on vacation, I think I got a buy-off from SIG scheduling. They were okay with Wang Wei has commented on the CAP saying the outstanding remaining issues can come in a separate PR. So it's we're at 2 out of 3 now, or 2 out of 4, I think. Tim is LGTM and SIG scheduling is LGTM. I'm wondering what all is left to get Node and CRI LGTMs. Thank you, Mrunal, for working on getting a guidance out. One of the questions that's still outstanding is how we should look at when you request a resize, especially for memory. If we cache it and then do it later, I think I'm not comfortable with that. If there is a series of updates, it could, you know, we order them from smallest to biggest, and if it's not really changing the limit and it's telling us yes we did it, or succeeding the update.
No, I think what we want to do in runC is make sure that it fails if it can't do the update, and we just propagate it back immediately.
Yes, yeah.
So that's the case for V1, and V2 we have an issue open, and I'll work with Kerr to get it.
Okay, I can work with you on Slack too. You know,
sure.
I think what this boils down to is I need to make another small change commit which updates the guidelines a few lines, I would say, on the update container resources API as to what the CRI expects. A lot more document or what we expect from the runtime, and a lot more detail in the documentation.
Yeah, I think that sounds good. Yeah, we can work on Slack. Yeah.
So Manu, can you check on the CRI related and
for sure.
Yeah. And also Riven, can you help too on this one? Yeah.
Yep.
I think Mike and Peter are good with what we have, I presume. Are they on the meeting?
Peter is out today.
Okay.
I don't see Mike either.
Mike is not here either. Okay.
Michael is not also here. Yeah. So, but I think you have Manu here, and also Riven also pick up on the container D recently. So that's why.
Yeah, he's got it ready. I know.
Yes. So we have the both side to cover, and also CRI cover, and also Node side cover for this.
Yeah. Okay. So hopefully when Derek gets back from vacation, we'll do one final look and get this boulder up to the top of the hill.
Yeah, let's really make sure this time we have one path for user to try.
Yeah. Thanks everyone. That's all I had.
Thanks, Vinay. And Andrew, please.
Yeah, I just wanted to update with the help of Mrunal and Mike. We did another round of reviews, and at this point, I think everyone is happy with the checkpoint container code pull request. And I think now we only need an approve from Derek, if I understood Mrunal correctly.
Yeah, we need an approve from Derek or Don because it has the API stuff.
So Derek will be available or is on vacation?
No, he's busy. I'll sync with him, Don, and if
Okay,
need be, we'll ping you for the approve. Yeah.
Yeah, if he's not available, just ping me and I'll take another look. Yeah, thanks.
Thanks.
I think that's all for today. Oh, and Sandra, you have one question. Sorry, from the chat.
Yeah, can everyone hear me? Sorry.
Yes.
Yeah, working good. Thank you. I was not able to add that item to the agenda. I'm really sorry. I didn't have edit privileges on that doc. Just wanted to follow on the email that we sent. I think that was last Friday. Was really not a long time ago, but we're looking for some feedback here on the SRO to KMMO transition for the management of out-of-tree kernel modules in Kubernetes. I'm just not quite sure how we should move forward with this. Are we looking for a lazy consensus, or should we give it more time? Or that's really the question I have for you today. I mean, it's only been 4 days and I've sent it before the weekend, so I would understand if people need more time to review, but I'm just trying to time box this really.
Anyone have any context on this one? Sorry, I didn't get what you asked, request here. Maybe we could move the discussing to the SIG Node channel, Slack channel there. Is that possible? Yeah, I'm going to join.
Yeah, that's exactly the SRO to KMMO transition, that email, yes.
Okay. Unfortunately, I don't have all the background, the context here. Anyone?
I guess, Quentin, let's move it to SIG Node and the channel, and then follow up next week. Yeah.
Sounds good. I'll write a recap on the channel then. Thank you all very much.
Yep.
Yeah. Thanks, and also Alexandra, I will reply to you about your question on Containerd. Yeah. See you.
Right. Bye. Yep.
Thank you.
Thanks. Bye.